Hello class, welcome to our third topic in the exponent unit, or exponent / scientific notation unit. And we're continuing our look at exponents. And today we're calling them integral exponents. And integral is a way of describing something as being an integer. So notice it's almost all there. Integer. So if you remember that as integer, and if you remember, integers are different from whole numbers in that they include negative numbers too. So if you look at the learning target, it says more specifically, I can rewrite numbers with negative or 0 exponents. So we're going to learn how to change your answer, because you don't really want your answer to have a negative exponent. You don't really want your answer to have a 0 exponent. So we're going to learn how to write them differently. And we're going to do that. We're going to take a look at two examples. We're going to start with this one that was x to the 5th over x to the 8th. And it says, remember this from last time, because in the last video we talked about how to multiply and divide, and then powers of powers. We learned some stuff about exponents already. So one of the things we learned was using the rule. We said, if we're dividing, we keep the base. So I'm going to keep this base of x, but I'm going to subtract exponents. So when you divide, you subtract. And you get 5 minus 8, which is x to the negative 3. And last class we just would have left it like that. And we're not going to today. But before we talk about what that really is, we're going to look at a different way of solving it, which is the expanded form. So x to the 5th is the same as x multiplied 5 times. And then x to the 8th is the same as 8 x's. Starts to look like a weird pattern here. 1, 2, 3, 4, 5, 6, 7, 8. And then I'm just going to cancel pairs, because x over x is 1, and that happens 5 times. And what's left is 3 x's, but they're on the bottom. And what's left up top, every time I canceled, there's a 1 left. So there's 1 on top. So if I did it correctly both times, then why am I getting 2 different answers? Well, it's because they're not different. They are the same. So I know that x to the negative 3 equals 1 over x to the 3rd. So what the negative exponent does is actually gives you the inverse of x. It kind of gives you the reciprocal, in a way, the negative reciprocal. Oh, I shouldn't say negative reciprocal, because it's not negative on the outside. It's the negative exponent becomes a positive exponent on the bottom. And something we say, and something you want to write down, is that negative exponents make fractions. I'm going to write it just in case you don't. Negative exponents, you probably have a better place to write this than I am writing it. Negative exponents make fractions. We kind of saw that with scientific notation. Remember when we had a negative exponent, it meant it's going to be a really small number. Fractions are really small numbers. So we kind of had exposure to that, but we didn't say it quite like that. Okay, and then this other one that has a to the 3 and a to the 3rd divided by each other. We're going to do it the rule way first. So a to the 3 minus 3, and we get a to the 0. And I kind of touched upon this again last time, but we mostly just left it like that. We followed the rules and moved on. But if I do it the other way, a times a over the same thing, they all cancel. And no, that doesn't equal 0, because every time you cancel, just like in the first one, it equals 1 every time. And if you multiply 3 ones together, you still get 1. So again, if I did it 2 correct ways and I get 2 different answers, it doesn't mean that it can't be true. It just means that these are the same thing. So in fact, anything to the 0 power equals 1. And that's one of those weird facts that makes math a little more interesting sometimes, because it doesn't seem like that should be the case. Why would something to the 0 power equal 1? And it equals 1 because it has to for everything in math to work. So it doesn't really make sense to say, normally if it's a squared, that means a times a. But if it's a to the 0, what are we multiplying a by? There isn't any. So it's a strange thing to understand, but easy to remember if you stick with it. Okay, we spent enough time on this slide. We're going to look at some examples, and we're going to start with negative exponent examples. This is what I want you to do while we're going over these. Well, I'm going over these notes, these examples. I want you to try to beat me. I want you to either pause it and try a couple and see if I answer the same way, or just stop it after each one just to see. Don't just copy down what I write and don't ever think about it. So I'm going to start, but you're going to keep pausing, hopefully. So 2 to the negative 2. If you remember from this first slide, if I have a negative exponent, that whole thing moves to the bottom of a fraction. So let's see if we can do the same thing here. This whole thing moves to the bottom of a fraction. 2 squared on the bottom, and on top, it's just a 1. And that pretty much happens almost every time on this slide. 10 to the negative 1 moves to the bottom, has 10 to the positive 1 over 1. Oh, and I could have went further in these. This is 1/4. This is just 1/10. You don't need that little 1 there. All right, 3 to the negative 3, again, moves to the bottom of the fraction, and you get 3 to the 3 over, or excuse me, 1 over 3 to the 3. And 3 to the 3rd power, that's 3 times 3 is 9, 9 times 3 is 27. 5 to the negative 2 is the same as 1 over 5 to the positive 2. So it's a very similar pattern every time here. And that's 1/25. Again, hope you're pausing between each one here. 1 over 4 to the 3rd. I think that's 1 over 64. And then finally, this one's a little different. It's 4 times 10 to the negative 2. Well, if I just look at this, that's stuff I've been doing. So let's just do that. Like, ignore the 4 for a minute. I'm going to leave room for it, though. 1 over 10 squared. I know that's what that part turns into, but I still have 4. Well, if I wanted to make it a fraction, because if I'm going to work with fractions, I want them all to be fractions. So 4 over 1 times 1 over 10 squared. Well, that's just 4 times 1 is 4. You just multiply straight across. And then 10 squared is just 100 times that 1, still 100. So 4 1/100ths. And it can reduce that one, kind of running out of room, but it's the same as 1/25. Alright, we're going to check out some 0 exponents now. So this is just a reminder, but this is the most basic example, is that x to the 0 power equals 1. In this first example, I have 4x to the 0 power. So all of 4x, notice it's like the parentheses are hugging it, and they're raising the entire thing to the 0 power. So it's still 1. I could actually put anything I want in the parentheses. I could write Mr. McCausland to the 0 power, and it's still going to equal 1. As long as I have those parentheses on there. That's different than 4x to the 0 power without parentheses. If you look right here, the 0 is attached to x, which is the base, but 4 is not a base anymore. 4 is a coefficient. It is not affected by that 0 exponent. So if you were to rewrite this, it would be like that last example here with the dot. So we're going to say 4 dot x to the 0, just to clear things up, just separate it a little bit. So I know that this becomes 4 dot 1, which is just 4. Alright, over here, 3 plus, and then the same exact thing is going to happen with this term. So I want to kind of think of it separately. I hit 3 plus 5 times 1. The x to the 0 is what turned to 1. I actually like going through and circling which part the 0 is going to turn into 1. So 3 plus 5 times 1. Remember, please don't add first. Although in this case, because you're multiplying by 1, it doesn't matter. You always have to do multiplying first. And you get 8. So notice this 0 is covering the entire 3 plus 5x. So because I circled the whole thing becomes 1 again. Alright, in the last page we're going to challenge you a bit with some combinations of the 0 and the negative exponents. I'm going to do the first two, and then you're going to do the last two. So in this one here, we have 7 to the 0. I'm going to circle what becomes 1, write a 1 underneath, plus. Now I have to think back to my negative exponent rule. I think this whole thing is going to become the denominator in a fraction, 6 squared at the bottom with a 1 on top. So that means I have 1 plus 1 over 36. And you can just leave that as a mixed fraction, 1 and 1/36. And then over here we have 4 to the 0. That becomes 1. But this time I have times. And then this becomes the denominator in a fraction. I could put the little 1 there, but you don't have to. And a 1 on top. So 1 times 1/4, when you multiply it by 1, nothing happens, so it's still just 1/4. Alright, so I want you to do, there's no numbers, but I want you to do this one here on your own, and this one here all on your own. Alright, I was asked by a couple students to, in the video, remind you that you need to do a summary. So please, please, please do the summary, and I'm not only going to remind you, oops, there's a little too many bumps on that M. I'm not only going to remind you to do the summary, but we're going to help you get a start on it. So remember, this might be a place where you can start every summary with the learning target. The learning target was, I can rewrite numbers with negative or 0 exponents. So the first question you should ask yourself is, can I do that? I said I can when I wrote the notes. So when I'm done with the notes, can I do that? Is that something I can do? And if the answer is yes, you should be able to tell me how to do it, or you tell your friend how to do it. So you might want to start your summary by kind of breaking it up and saying, wrong marker, I can rewrite numbers with negative exponents by, and you fill in the rest. So it's a little sentence starter. I can rewrite numbers with negative exponents by blah, blah, blah. You tell me the rest. I don't want to put words in your mouth. And then you're going to have another sentence. You can probably guess what it's going to be. I can rewrite numbers with 0 exponents by, and give me any tips and tricks that you picked up along the way. There's not a whole lot new that you learned, so it should be pretty easy to put it all into the summary. Also, try to think of one question. If you can do this, your notes will be fantastic. Alright, good luck. I'll see you later.